Okay guys, I'm now looking at the visual learning page and the Convince Me for lesson 9-3. Make sure you watch the video on Pearson Realize. I'm going to jump down to the Convince Me. The question says, use the same numbers in the multiplication equation 15 times 1/3 equals 5. To write a division equation, draw a diagram to show that your division equation makes sense. So all we're doing is we're taking the same exact numbers. We're not changing any of the numbers around. And we're going to turn this problem now into a division sentence. So before we jump into the fractions, with regular whole number multiplication and division, I can take a problem like 5 times 6 equals 30. And by just turning the operation around to division, but leaving the actual numbers themselves the same, I can come up with another number model or equation. So if I were turning this into division, I could say 30 divided by 5 equals 6, or 30 divided by 6 equals 5. Either one of those would work, and again, I didn't change anything other than the sign. So if I'm doing the same thing here, I started with, again, 30, which was my answer to that multiplication problem, and I ended up, when I did division, using that 30 in both number models as my dividend. So when I am doing the number model here, 5 was my product, my answer to my multiplication sentence. So 5 is now going to be my dividend in my division problem. So it's going to be 5 divided by, now I have a 15 and a 1/3. So in this case, I'm going to use my 1/3, my fraction, and my answer then, my quotient, is going to be 15. Now, if you think back to the solve and share, when I said what we can do with the fractions in order to do the division, if we do that same thing here, remember I said I can take this divisor, 1/3, and if I flip it over and I turn it into 3/1, I then just need to also switch my sign. So I'm going to switch my sign back to multiplication, and I end up with 5 times 3/1, or 5/1 times 3/1. And I know that 5 times 3 is 15, and 1 times 1 is 1, which gives me 15. So this is a way for me to just check to make sure that my number model still makes sense. Now, they also asked me to draw a diagram to show that this was actually going to work. So in this sense, I'm going to start with 5 of something. So I'm just going to draw rectangles here. Okay, so I have 5 rectangles, and I'm dividing my 5 rectangles into thirds, into pieces of 3 each. So what I'm going to do is I'm going to cut each of these rectangles into thirds. So it's divide each of the 5 rectangles into thirds, and then how many total pieces do I now have? 3, 1, 2, 3, 6, 9, 12, 15. That's where my 15 comes from. Okay, so this is my division model that I got from this multiplication equation. This is how I represent it visually in a diagram. Okay, that was the Convince Me on page 540. So if you're in the Google Slides, there you go. I'm going to jump now to the guided practice on the next page before you get into the independent practice. So for the guided practice, they start with explain how to use multiplication to find 4 divided by 1/5. So again, 4 divided by 1/5 we're trying to find the answer to that. Again, going exactly to what I just did in the last problem, I'm thinking about this in terms of if I flip it and turn it to a whole number, this one's going to be 5 over 1, or 5 ones. I'm switching my sign, and I now have 4 times 5, or 4 over 1 times 5 over 1, which gives me 20 over 1, or an answer of 20. Again, even though they don't ask for a picture here, I just want to show you that so that you can see why it happens, because it's not always enough to just say, flip my fraction over. I want to know why I'm actually doing that. So again, I'm starting with 4 of something. And this is telling me to cut each of the 4 into fifths. So I'm doing fifths for all of them. And then once they're all divided into fifths, what I'm really doing is I have 5, 5, 5, 5 pieces, and I have 4 total, whatever we're starting with. So it's 4 total items times 5 pieces per item. That's where my 20 is coming from. Okay, so one method, if you still need to actually see it, it's fine if you want to draw them out so that you can make sure that you're really understanding. Again, my whole number is how many I'm starting with. So if you think about something like candy bars, I'm starting with 4 candy bars. I'm cutting each candy bar into fifths so that if I were going to share them, I have candy bar number 1 is in fifths, candy bar 2 is in fifths, 3 in fifths, and 4 in fifths, and then I'm saying how many individual pieces do I have between the 4 candy bars. Okay, that was question number 1. For question number 2, they said, show how to use multiplication to check your answer in exercise 1. So I know that I can always do the opposite operation. So in this case, if we did that problem, I have 20 total pieces, right? And then I'm going to say each piece is a fifth of a whole. And if I do the multiplication now, I do 20 times 1 is 20, 1 times 5 is 5, and I get back to 20 divided by 5, which is 4. 4 is how many candy bars I actually started with. Okay, so for question number 2, we're just checking up on how we answered question 1. For number 3, they want us to find 3 divided by 1/10. So again, I'm thinking about it in terms of, I'm going to flip over that fraction first. So I'm going to say 10 over 1. I'm going to turn that into multiplication. So really I'm doing 3 times 10, which gives me 30. Okay, because I'm basically dropping the 1 because 10 over 1 is the same as 10. Again, you can do that and multiply across. You're still going to get 30 over 1, and then it's going to simplify down to 30. Again, they didn't ask for the picture for this one, but I'll give you the picture just so that you can see. This time we have 3 of something, so 3 candy bars, for example. And this time I'm cutting each of them into 10 pieces. So I'm going to do my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just want to make sure I have the same number of pieces in all of them. Two, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so obviously If I was really cutting them into fractional parts, they would need to be exactly the same size because remember fractions means fair shares, but 3 divided into pieces of 10 per candy bar would be 10, 20, 30. That was the same 30 I got by doing 3 times 10. Okay, for number 4, this time they wanted me to draw a model, which we've been doing for each of them anyway, but draw a model to find 2 divided by 1/6. Whole number, again, is how many wholes we're starting with. Fraction is telling me cut it into that many pieces per whole. So I'm cutting them into 6 pieces per whole. 1, 2, 3, 4, 5, 6. And when I add them together, I have 12 whole pieces. Okay, and again, I can flip my fraction, 6 over 1. 2 times 6 over 1 is 12 over 1. I'm sorry, 12 over 1, and that equals, 12. Okay, that was number 4. So my answer again is 12. And then for number 5, they want us to use a multiplication equation to check our answer for number 4. So we're just going to take our answer of 12. We're going to multiply it by the fraction that we started with before. So 12 times 1/6. And I'm doing 12 times 1 is 12. 1 times 6 is 6. And 12/6 is equivalent to 2 because there are 2 6s in 12. Okay, so again, we solved. Your choice about how you want to do it. If you want to do the picture each time, if they don't ask you, again, you can still do it. Ultimately, we're looking for that final answer. When I do the multiplication, same thing. I'm using the same numbers all the time. So you see it here. I have a 12, a 6, a 2, a 12, a 6, a 2. The numbers themselves will not be changing between the multiplication and division. When you do the check, all that is changing is that you are going through, switching the operation, and making sure those numbers all stay the same. Okay, that was the guided practice for 9-3. If you have any questions, please make sure that you ask. You are going to be doing the independent practice, which asks you to do the same thing. So you're going to use models. Obviously, you can't draw the models into the Google Slides. So what you can do to help yourself is if you have scrap paper on the side, you can draw out the model. Again, it's only for you to make sure you know what you're doing, and then you can put your final answer into the Google slide. Okay, and then the second part, they want you to use multiplication to check your answer. So provide the answer and then do multiplication to check. Any questions?